5, 4, 3, 2, 1, 0. All engine running. Liftoff.
Hello, space enthusiasts. Welcome to another episode of the Space Business Podcast, where we investigate all the exciting ways in which people participate in the new space economy by conversations with entrepreneurs, executives, investors, and other members of the space family. My name is Raphael, and I'm an investor in and advisor to space companies. Just as a reminder, this podcast is for informational purposes only, and nothing should be taken as investment advice. This podcast is sponsored by Nanoavionics, a satellite bus manufacturer and mission integrator. Their satellite technologies enable many space companies worldwide to offer services that improve life here on Earth, such as providing global connectivity, conducting Earth observation for various purposes, or contributing to scientific discoveries. Check them out and also check out my episode with their CEO and co-founder. Sadly, I am not a rocket scientist, but I'm an alumnus of the International Space University, or ISU, which is also our partner in this podcast. ISU offers a number of educational programs about space worldwide, ranging from executive courses lasting a few days all the way to a one-year master's. Check them out at isunet.edu.
In this episode, we'll talk about rockets, yes. Specifically, I sat down with Stefan Brieschenk and Jörn Spurmann, co-founders of Rocket Factory Augsburg, a German small launcher. RFA has a number of peculiarities that make them stand out from the growing field of small launch startups. For example, they're already backed by strategic aerospace heavyweights in Germany. Also, they helped trigger what is by now a serious discussion as to whether Germany should have its own space launch site in the North Sea. Hear about this and many other things in this episode. Let's go for launch.
Hey everybody, welcome to another episode of the Space Business Podcast. I'm joined today by Jörn Spurmann and Stefan Brieschenk. They're both co-founders of Rocket Factory Augsburg. Welcome, guys.
Hey, hello. How you doing, Ralph?
Excellent, thank you. Guys, let's start as we always start in the same way. Why don't you give us the 2-minute elevator pitch on Rocket Factory Augsburg?
So Rocket Factory is trying to disrupt the European scene of the launcher business by developing a new launch vehicle, but not developing it from scratch. In fact, we're the first company out there that basically is approaching this with built hardware, qualified hardware, and systems that are already flying. For us, it's a simple build project. We don't have to really develop a lot of things. We just have to put existing things together. And as such, we believe that we are going to succeed in developing a launch vehicle and a launch capability at a lower cost than anyone else out there.
Okay, so you're basically, colloquially speaking, literally a rocket company, which of course is very exciting for the average person because it's something tangible that everybody can imagine what a rocket is, which is, it's other parts of the space sector are not as tangible necessarily for the average person. So let's just delve a little bit more into that. Can you give us some more basic details about your rocket? Like, for example, how big it is and how much it can take to space?
So it's basically a good comparison is it's about the same size than the average church tower here in Bavaria. It's about 2 meters in diameter. It's about 25 meters long. And again, the unique aspect here is that nothing is developed from scratch. If you look at any of the systems, they all come from either existing products or previous development projects from our investors and partners, MT Aerospace and OHB.
And how much payload can you take, say, to low Earth orbit?
It's about a ton in the final configuration.
Interesting. So that's just off the top of my head, since, of course, at my investment company, we try to track all of the space companies and all of the launch companies as well. So that's a little bit more, actually, that some of the well-known other small launches, like I think Rocket Lab is about 225 kilograms and Virgin Orbit Launcher 1, about 500 kilograms. How did you guys come to decide to have that slightly bigger payload size?
So this is it's a very interesting story because basically, one of our main investors, OHB, they track the market in great depth and great detail. And they have a certain, how shall we call it, they have a certain information advantage on a lot of the smaller companies on how constellations will look like in the future. that was the pivotal element that basically allowed us to choose a reasonable size. A couple of years ago, everyone thought these mega constellations are going to exist out of CubeSats, but the reality is that a CubeSat is way too small. If you want to have a realistic size for a satellite in a constellation, it's of the order of a few hundred kilograms.
And that's right. I mean, certainly, again, at my company, talking to space companies, we're seeing exactly the same trend that, like you said, a few years ago, there was a lot of excitement about small CubeSats. And again, for our non-technical audience, a CubeSat is basically literally a cube where, it has a side length of 10 centimeters. So it's 10 by 10 by 10. And then you put various cubes together. But even if you put 3 or 6 of these cubes together, there's obviously a limit to the capabilities you can put in there. And that's why we're seeing companies like SpaceX now. Their Starlink satellites are 223 kilograms. I think that's what you're referring to here. Just coming back to your rocket and just some other details on that. What kind of fuel are you guys using? I assume it's a liquid rocket.
Yep, it's a hydrocarbon fuel. It is a derivative of kerosene. It is made specially for us. We developed this fuel blend with the distillery that's working together with us in Europe. Our aim there was to basically get as close as possible to something like RP1, but produces at a significantly lower cost.
And that's of course interesting because, like you said, most people would use RP1 with some exceptions. Obviously, now famously, SpaceX and the Starship will use methane. Some people are using hydrogen peroxide. But so, have you guys succeeded in that design objective that it's now a significantly cheaper fuel?
Yes, we're very glad that it has gotten to this point. The rocket engine we're using is basically, it has systems and components that have flown to space before, and that they basically need some slight adjustments, but they're very minor. But the fuel we use is more or less unique, and also the manufacturing method, the distilling process is more or less unique. We're super happy that we are convinced that we have a propellant combination that overall is just the lowest cost propellant combination that you can have right now.
Correct. And I assume, obviously, when you say that lowest cost, it's sort of like normalizing for the performance, for the thrust and specific impulse and like all of these metrics.
Yeah, we go one step further there. We always normalize to payload in orbit. We have a really fantastic optimizer tool that allows us to do all these cost trade-offs directly towards the final parameter. So we normalize everything actually by payload into space then. And we looked at other fuels, but we realized that the lower densities often don't pay out. And we have a very efficient motor design. It's a staged combustion engine.
Yeah.
We believe we're the first rocket company that uses such an efficient engine cycle in this new space environment, or one of the few that are actively working on it. And if you do the cost trade-offs there with this type of technology, you realize that kerosene is the best solution to lower the cost for the customer.
Is that fuel going to be easy to provide worldwide, like no matter where your customers are launching?
Yes, yeah. It's super easy. We actually have it already delivered to different countries, depending on where we have our test infrastructure. So it's not an issue.
Are you guys using your own engines designed in-house, or are you using third-party engines?
So we basically, what we have is we have engine development partners that have hardware that has flown to space. And we arrange it in a manner that we reduce manufacturing costs, but we don't necessarily give up all the qualification that already exists on the turbo machinery, for example. A lot of these components we leave unchanged, or we only make slight adjustments. In some components, we really only change the manufacturing methods. So overall, we don't have an engine that has a technical readiness level of 9, but we have something that is significantly higher than any from scratch development. So we arrange it in a fashion to allow low cost efficient manufacture, just as you would expect from a southern German sort of automotive minded company. And this is basically what we've done. But we have all systems on the rocket engine have a very, very high TRL.
Where in the timeline has that rocket engine, for example, has it been test fired?
We've test fired the pre-burner and the turbo machinery. The power pack itself has been test fired before it ran for 600 seconds, not in Germany. And we are just assembling it now into the first integrated prototype motor. And we're going to test this within the next couple of months.
Okay. And then coming back to cost, which you started mentioning in the context of fuel. So ultimately, when the rocket will fly, what kind of cost are you expecting to the end customer who's flying the satellites on your rockets, let's say to low Earth orbit?
We are trying to achieve a price point which is 10,000 euros a kilogram. So our goal is to sell this launch at an absolute price of 10 million for 1 ton.
Okay, understood.
Consider the benchmark of SpaceX at the moment with, let's say, 1 million for 200 kgs. We have the reduction potential to step down from this 10 million to make, let's say, a competitive offer. At the same time, a small premium for a small launcher to get you exactly where you want in the taxi manner compared to the bus ride on the SpaceX. This is what we believe this will come down to.
I think that's a very important point you're making here, and which we should at least briefly mention because not everybody may be aware. So, of course, as I alluded to, we're tracking all the space companies at my investment fund, and there's, I think, on paper, something like 200 launch companies. Of course, many of those, haven't really done a lot yet. But even if you take those out, which haven't done anything, you're probably left with a few dozen companies which have tested hardware in certain stages, and then you have SpaceX, and then maybe Blue Origin come online and everything. But as you mentioned, this comparison is a very good one that I also myself use very often, that the big rocket of SpaceX is almost like a bus where you're flying together. If you have a small satellite, you're flying together with many other people. Whereas you guys, you compared it to a taxi, right? Sometimes I use the comparison jumbo jet or charter jet and private jet. I think the point you're making here is that you guys can take the customer satellites to exactly where it needs to be and pretty much when he wants to launch.
Exactly. That is a core advantage of our launch service, getting the customer exactly where he wants to go and when he wants to go, saving them time and accelerating the time to entry into service with their data service. They don't need to wait 12 to 24 months for a launch. We can be just quicker there. And we have on our launcher an orbital stage that gives flexibility on orbit to do phasing for constellations, to do small inclination and run changes. So we can actually have this unique advantage to offer our customers some flexibility when he is arriving on orbit.
And I assume you would not just be a company producing rockets. I assume you will be like a full service, like launch service provider, right? Like people can come to you with your satellites, you do the payload integration, you arrange for the actual launch, you find a launch site and all of that.
This is 100% correct. And we even can go one step further. Stefan mentioned that we have OHB as a strategic investor in the back. And with that in a combined manner, we can go so far that if someone has an idea of what data he wants to produce from space, there's capability at OHB to create and manufacture payloads, to have platforms, to join this in a unique manner with our launcher and the orbital stage. And we provide the full end-to-end launch service on that. So it can be all out of one hand to deliver data products right away from space.
That's very interesting. And then just finishing up on the rocket, is it reusable in any way?
Yeah, absolutely. The rocket is reusable. It's the background is very simple. We have a really leading, I would say, state-of-the-art optimizing tool. And this optimizing tool works with cost functions and all sorts of engineering inputs. And when you ask the optimizing tool, what is the lowest cost for the customer, it wants to use a reusable stage, a reusable first stage. So it's vital. It's the reusable first stage will not be introduced into the vehicle in the first couple of flights, but it will eventually become part of it.
And how would that look for you guys? Is that going to be like a propulsive landing like SpaceX or something like Rocket Lab with parachutes and picking it up on the way? And
we have our own ideas. It's most likely a propulsive landing, but it will look different than what the competition is doing.
Interesting. So we're certainly looking forward to that because that's always really exciting to watch, of course. And then speaking of launch services, I already mentioned, obviously, you guys ultimately also have to find spaceports where your customers can launch from. What's the plan there? Where do you guys envision launching from?
There are several options in Europe that we're currently evaluating. More and more clears out that our baseline will be Andoya, since they seem to be ready in time when we need it. There's more activities going on. We have a very flexible concept regarding a launch platform that we can very easily, let's say, deploy on any launch site. Ideally, we find the way to get into agreements with as many launch sites as possible around the world to do this in a flexible manner. Because our ultimate goal is really to be close to the customer, and also that means regionally launching in a close proximity to where the customer is actually located.
And of course, you are based in Germany, and since I'm German myself, I follow a little bit. There's I think a developing discussion in Germany whether Germany should also develop its own spaceport. I'm just going to guess that you guys are in favor of that for obvious reasons, but maybe if you can just give your thoughts and sort of the rationale of why you might be in favor of that.
No, sure, we are in favor of that. I would go so far that it was even our idea. It all started in October last year with the Space Congress from BDI, the let's say, agglomeration of German industry representatives, and they had the idea of putting up a spaceport in Germany, suggested 2 locations, and we found that the North Sea actually with a platform makes most sense in there. If this really comes into play now as an open concept to be used by multiple launch vehicles, we would definitely be launching from that spot. It creates a lot of efficiency and synergies for us and makes it much more simple in terms of logistics and export control to launch than just from Germany.
So yeah, the idea, I have to say, the idea was actually born in Jörn's team. I mean, they looked at a map and they realized for the first time, I've never heard about this, that Germany doesn't end at the border that you see on the map, but there is an economic zone, indeed, that is in very shallow waters, and there are platforms that have extendable legs that already exist. They're right there, and you can buy them for a very competitive price. So it all fell into place right then.
Should I imagine this sort of as kind of like some sort of oil rig platform?
Yeah, it's actually could be an oil rig platform. Our idea would be to use the renewable energy industry, wind turbine industry. The ships that are used to deploy these offshore parks, they would be perfectly suitable to also take launchers, right? The pillar of such a windmill is much heavier than actually the dry launcher that we have. So it's easily capable to transport that. You change the ship a bit with the container logistics for the fuels, and there you go. You can directly do it.
And so if everything goes well on your development timeline, when do you envision to have the first flight of RFA-1?
We think we can do it within 2021 if we have aggressive funding. But we have to be honest here. We are still looking for financial partners. We have really, really strong financial partners, MT Aerospace and OHB. But we are looking for further financial partners to help us on that mission. And it's a question of how much funding comes in at what time.
Yeah, we'll definitely talk about the funding question. That's always an interesting aspect. The startup at your stage, obviously. Okay, so 2021, that's actually sooner than I thought. So are those spaceports that you mentioned there, like Andøya? I think Andøya is in Norway, right? Are they planning to be ready by that time frame?
Yes, it is in Norway, and yes, they have a timeline that would help us to launch within next year. Yes, they have a multi-step approach of implementing their launch site and could make it happen to accommodate us in next year.
Okay, interesting. And they'll have all of the infrastructure that you need. I assume you need, obviously, since you're liquid rocket, you need like the liquid oxygen tanks, the tanks for the hydrocarbon fuel you're using, and all of that stuff.
Yes, they would. The good thing about Norway is they are experienced people in launch business. Yeah, they have a sounding rocket range which they are operating since a couple of years, and they exactly know what needs to be done. Also in that environment up there, and to make rocket launch possible. And they are just extending this now to a bit bigger vehicles going orbital.
Yeah, and thinking about it, they also have a lot of hydrocarbons, a lot of experience handling hydrocarbons. So I guess that part is easy too. I wanted to speak a little bit quickly about sort of your customers. Where do you see your main customer groups, and sort of what is the status of discussions with those?
There's a worldwide market of customers. There are lots of satellite customers. We have good discussions ongoing. We just announced that there's a partnership with Exolaunch as a broker helping us. There will be others in the same sort. We have pre-contract signed within the OHB group who are acting as an anchor customer with us. There are more launch agreements coming into play. So our pipeline is several hundred millions of euros. So there's a good market out there. We just need to get the product ready and commercialize and industrialize the launch service.
And is that substantially, that pipeline is substantially commercial space companies and new space companies with things like communications and Earth observation satellites and that kind of stuff?
Yes, exactly. So the major applications we see for small satellites from LEO is Earth observation with different sensors. It is communication. Some are even going into GPS and positioning services. So the application base is increasing on a yearly basis as well as are the customers. And it's a solid mixture of commercial customers, small satellites, but also bigger, and also institutional customers and missions which fit our 1-ton vehicle.
Institutional customers, that's a good point. How does that look in your pipeline? What's your experience? Because, I know SpaceX pretty well and the other US launchers. And of course, it's fair to say they've all had substantial assistance via government contracts. I mean, obviously NASA, but then of course also the DoD, the Department of Defense, and then various branches of the intelligence community and all of that. We probably have a little bit less in Europe. I don't know. How do you think about that? Or do you have like a good pipeline of government related contracts as well?
For sure. The civil space market, and not to talk about the defense space market in Europe compared to the US, is a factor 3 to 5. Yes. So it's a significantly different. You're totally right. The US is much bigger in that sense. Nevertheless, I think the wave in Germany in terms of small satellites, new space environments, small launchers is increasing. We see that Germany has taken a leading role here on the last ministerial conference. They are now buying 2 launch services from companies in Germany for their payloads. And I hope that in the next European framework that we will see, there are also similar means to support that. Nevertheless, this can never be the, let's say, fundament of a business case, but it's definitely helping if there's support for sure. And I see that this is positively evolving. Yeah.
Is there also support out of people like ESA for you guys, maybe with like science missions or other types of missions?
I think this must be the goal. That at the moment they have no other option. If you look at what vehicles are flying out of Europe, it's Ariane and Vega. There is no other vehicle flying. So at the moment, on paper, they don't have any other option. But as soon as commercial micro launchers are flying and are successful, I don't see any reason why they should not fly with it and why this shall not change.
Yeah. And I guess taking sort of a step back and looking at the space economy from a broader point of view, I've looked at your site and on your website various times. You're talking about sustainability, which is also something that's close to my heart. You guys are effectively one of the companies that are actually enabling the whole space economy, right? Because you're providing the transport capacity. What would you like to see in space? What would you like to see that is going to fly on your rockets?
Humans.
Okay.
It's a good point, right? It's taken Elon Musk, 16, 18 years to fly someone into space.
Yeah.
That's way too long. This is way too long, right? For a thriving space economy, we need not only commercial payloads, but we need to fly people into space and to different planets. And this is just the first stepping stone. We think that this is going to become more and more vibrant and relevant in the future.
So is that literally part of sort of the medium-term vision of the company? You guys want to develop a human-rated vehicle at some point in time?
I think it's a vision of everyone who's working in rocketry. That humans have always been pioneers, and we are launching humans into space since 50 years by now. The only reason that this is not a mass travel society is because of the price, and we need to tremendously reduce that price just to make it available for everyone. And the borders of human mankind is currently Earth, and we need to move beyond that. Earth will be very crowded very soon, so we need to find new space.
And there's a good story here because we are really poised to make this happen. If you look at our main investor, OHB, they tell us how the satellite of the future looks like. And if you look at the satellite of the future, you realize one thing: it's a lot more fragile than the satellite of today. And this requires launch vehicles that have much more benign environments. Maximum accelerations below 4 Gs. We're talking about 3.5 Gs max.
Yeah.
More or less no vibration. And if you look at that, you very quickly realize if you can launch this sort of future fragile satellite on a vehicle, you basically have your man rating.
I see what you're saying. Then basically, simplistically saying, all you then need is, because you're within those physiological limits, for example, of the G-forces, you just need to basically tag on an environmental control life support system, and you can launch humans.
Yeah, theoretically.
And so, coming on from that, where do you see sort of if you had to look, 5-10 years in the future, where do you see how do you see the launch sector evolving? Again, like right now we have this 200 companies on paper, the majority of them are small launchers, like yourselves, although, you are the top end, I guess, weight-wise for the small launchers. Then you have the medium launchers, you have the heavy launchers, like something like the SpaceX Starship that's coming online. How do you see this all playing out?
I think that the entire space domain is just going to grow at a massive rate, and we really need this. What we have noticed in history is that the best times for the overall economy were the times of the space shuttle, because there were so many spin-off technologies that basically spun off into commercial real-world products, and we sort of lost that. We haven't done this enough in the last 20, 30 years. It's an element that we need to put back into the economy, and this is why governments have to increase spending on R&D, in particular the R&D that's very, very hard to do, and that's space travel. That's doing things in space. If you look into the US, they actually went all the way now and founded a Space Force. Yes, it's a military institution, but this is just, it highlights where all of this is going. It's the next big thing, going into space. And commercially doing things in space is just the next big thing. And we think that there is a massive growth that will happen everywhere on the planet, not just in the US.
And of course, being a space investor, I'd naturally agree with that. I think the space economy might grow to trillions of dollars over the next decades. And worldwide, like you said, and you mentioned Space Force. Of course, France also established its own Space Force last year. So it's really everywhere. India, China, Japan, Australia, wherever you look, there's a lot of activity now in space. Now, you mentioned governments, and of course, I agree, governments have to continue supporting this, partly because some of the technology is really on the frontier, and the sort of the time to return may take quite a few years. However, I personally think we need to get much more, private capital, private investment involved. And that brings me to the topic which you already mentioned at some point, which is basically financing. How are you guys financed? How has your fundraising experience been, and where do you stand now on your fundraising?
It was a good discussion lately somewhere on social media, comparing how much money you need to put a small launcher into space. Different examples, I think, so far. If you look at SpaceX, Virgin Orbit, Rocket Lab, and a couple of others, we believe that with around 100 million euros, you can do it to get to a first launch and find the means for industrialization. And we have strong investors in our back. They have already put a lot of money in. They are open to put more, and we have commitment. And nevertheless, we are open to take more financial investors on board. Stefan just said it. There are good talks. We are in very good discussions, and disclose a bit more when it's getting final.
And so what you already mentioned a few times now, this is a very interesting point. You have those strategic companies, so OHB, very well-known, very traditional German space company, even publicly listed on the stock exchange, and then MT Aerospace as well. How did that come about? What's the reason for that, the decision-making process to start working with strategics at a relatively early stage?
We initially Stefan and I met on a project with MT Aerospace on micro launchers. And out of that, we looked very independently with the optimizer tool Stefan mentioned, what makes sense in terms of developing launch footprint. And from that, developed this idea of Rocket Factory. And we convinced the owners of MT Aerospace and OHB to spin off this company and to get it going. And we are completely independent. We can work completely free and have them in a supervisory board and meet quarterly to discuss important stuff. So it's going really well.
Yeah, and just technically, for me, technically, the real breakthrough was that we have this optimizer tool. It's basically, it allows you to optimize 20, 30, 40 parameters at the same time. And what we've done for the first time that this has happened anywhere in the industry, we basically coupled large databases of pure cost functions into it. And now for the first time, you could use this tool to not ask for a technical optimization, but a pure financial optimization. We got to the point within a year's time where we could ask the optimizer literally, can you tell us how the entire trajectory, the vehicle, the manufacturing looks like? Can you tell us the materials, the wall thicknesses? Can you tell us the manufacturing methods? Can you tell us the type of engine if we want the lowest possible cost of a mass, a payload in orbit? And this technically for us is a huge breakthrough. It was only possible with all these cost functions that MT Aerospace and OHB had. If you have a startup without any experience, you don't have access to this, right? Think about just an example on a tank. A tank can be made out of different wall thicknesses, different materials, different sizes. And now the key element here is that you have a matrix that can tell you exactly how much it will cost, right? So the optimizer can basically ask how, if I make the tank in this construction method of this wall thickness and I put that much acceleration on the vehicle, this is how much does the tank cost, and the optimizer will know. And we believe this was a technical breakthrough that other companies do not have.
So that makes a lot of sense. When you're speaking now to, let's call it like non-strategic, like financial investors, right? I mean, we often very joke, right, in everyday life when we say something like, oh, this is not rocket science. Well, this actually is rocket science. So how have those discussions, gone with non-strategic financial investors? Like, are they able to get their head around this rocket science? And if not, like, what do you think we can do to kind of educate people more on space in general?
There are a lot of investors already, especially financial, which are involved in space industry and space business, and they pretty well understand what this is all about. So it's easy to explain. There are a couple of people who are not investing in space at all. They are not interested, so there's no reason to explain. So it's a mixture. But essentially, I would say the people who are interested, yes, they know what we are talking about. So there's very little to explain. Launch is very simple to understand. You show a spaceport, you show a rocket launch, everyone grasps what it's about.
And then just coming back to sort of the market segmentation for a moment, I mean, because you're at this size class of 1 ton to low Earth orbit, I mean, off the top of my head, I think there's actually, I mean, I keep on mentioning 200 launch companies on paper, but actually I think in this size class, there's very, very, very few. I mean, off the top of my head, I can only think of Relativity out of the US with its Terran rocket, and then also out of the US, / Ukraine a little bit, Firefly with its Alpha. Do you ultimately think this is going to be a market where, for example, the lowest cost wins, or there's going to be some sort of natural geographic segmentation, or the market is just simply big enough that there's going to be several companies? Or how do you look at that market segmentation with your, let's say, more immediate competitors?
I think you're perfectly right. These are the two major competitors we have in that segment. And we believe that it has exactly the right size to suit the market need best. In offering also the low cost point of view. If you go too small with a launcher, you will never reach a good price point, and we don't want to go too big for the first project. So this is the exact sweet spot that we found, and this is verified with what we see in the market and the, let's say, feedbacks and contracts that we are signing on with customers. So yes, it is the right competition, it is the right sweet spot, and I think it's perfectly matching what we need at the moment for the small satellite industry out there.
And I want to change tack a little bit, because you guys are based in Augsburg, and that's probably not, what sort of your average person worldwide thinks of, like, big space cluster. How has the ecosystem been in Augsburg? How has it been being based there for you?
No, it's very good, because if you look, Augsburg is it's a space city. We have MT Aerospace. Augsburg always made launch vehicle components. And it's a high-tech spot within Germany. We have lots of automation companies. We have lots of really strong mechanical and space engineering companies that are smaller suppliers. And we think it's super strong. But the main advantage of us being here is that we have the entire supplier network of our investor companies, OHB and MT. So when we get parts made, even though you might think that when you hear these big names like OHB, you might think that these parts end up being expensive. But what we've realized, they're cheap as chips. No startup could source these parts as inexpensively as we can, because we have access to a global supply network that's basically already established. They're making huge quantities of parts. So if we basically just push in one for Rocket Factory, it makes almost no difference. It's going to it's basically coming to us at a price point that is, it's really disruptive. You can't compare it with a startup that goes somewhere and asks a supplier to make a part from scratch.
Right. And is all your testing and integration, is that all happening right there in Augsburg?
Yeah, and this is also the cool thing. And if you look at MT Aerospace, they have all the testing equipment there, from large vacuum chambers to vibration tables to large, strong floors to do structural testing. The really cool thing here is that we don't just have a financial investor, we have a strategic investor that gives us so much capability that we really think that when it comes to later on to payload, cost, and overall funds spent, overall non-recurring costs, I think we have the best chances to beat everything that is out there.
Are you test firing the rocket engines also in Augsburg?
We're test firing not in Augsburg. We're test firing actually in Sweden at S-Range, and our preparations are basically completed now. We disassembled the test stand right here in our facility in Augsburg just a couple of days ago, and it's already on the trucks to go to Sweden.
Okay, cool. Yeah, I was going to ask about that because I looked at your job board and I noticed that besides Augsburg, you had Kiruna in Sweden and you had Matosinhos.
Exactly. We started this roughly, these discussions 1.5 years ago. We are poised to be there first and test the rocket engine in Kiruna within the next couple of months.
Cool. And that's probably also, Kiruna is very big and wide open spaces, so that's going to be easier with neighbors than test firing rocket engines in Augsburg, clearly. What is happening in Portugal, in Matosinhos?
We have a partner there who is very good on composite manufacturing, and they have great capabilities to build this cheap. We have some equipment on our launcher which is out of composite, and we are starting into projects together with these guys to get it industrialized and cheap as chips, as Stefan said, into our launch vehicle.
Cool. And like I mentioned, I noticed these locations because I looked at RFA's job board, and anybody who's looking for a job, there's quite a few positions on the job board. So I'd encourage everybody to go and look at that if you are looking for a space job. And it's engineering as well as non-engineering positions. Speaking of which, so I think you guys both have technical backgrounds. How has it been kind of building the company where I guess ultimately you also have to build out the non-technical, the business part of the team? How was that experience for you guys?
Yeah, basically everyone here has a technical background, but it doesn't have to be a technical background that you gain through university education. This is very clear.
Yep.
We have people here that have not gone to university. We have people here that have trades that have nothing to do with technology, yet they bring technical background simply because they're space enthusiasts. The official education way is just one way to become a technical expert, but there are heaps of people who just learn themselves out of their pure own motivation. And you will not find a person here at Rocket Factory that isn't crazy about rockets and crazy about providing a really disruptively different launch service.
Yeah, and I think you asked also around how was it with a technical background to build the company. On that sense, building the company is easy if you have the technical know-how and what you want to do. For us, of major importance is that we create a kind of a family spirit here, and we just tasked every person to take the same decisions as they would do in their private life, and if it was about family members. And then everything else comes together pretty easily. Because you know that every family you will probably associate and look at is working as well. So this is the only reason and the major reason why our company is working so well as well.
Winding down, coming towards the end, but you mentioned a formal education anyway. And Stefan, I can't help. I was looking at your profile and I noticed the topic of your PhD thesis, which was laser-induced plasma ignition studies for scramjet propulsion. So, okay, that sounds super exciting and interesting. So I just can't help asking you for like a couple of minutes. So beyond today's chemical rockets, where do you see the future of rocketry going? Like, is it like nuclear thermal? Is it something completely different? Like, what's the next step that we may take as humanity in rocket technology?
Yeah, look, I think the first thing that's evident is that eventually any rocket that has to compete out there will become staged combustion. There's just no other way around it. Staged combustion is the king technology, and it's not harder if you're smart. This is the difficult thing to understand. It's not more expensive either. If you look at a gas generator versus a staged combustion motor, yes, it is slightly more complex, but you can compensate for this easy if you have a really lean supply chain.
Yeah.
So this is the first thing. And we see this with Blue Origin. We see this with SpaceX. Eventually, sure. If you want to compete, it's staged combustion. The entire hypersonic scene is kicking off as well. It's unfortunately a lot of military capability. This was what I was working on, air-breathing hypersonic rocket motors that are unfortunately primarily aimed for usage by military. But just recently, NASA announced that they're looking again into nuclear propulsion, yeah. And this is not something that is too crazy to do. It's not something that's too crazy to do. And the most important thing is that governments have to wake up. Governments have to understand, if you want to run an economy well, you need a sector that basically drives all the R&D. And again, in the 60s, that was the space shuttle in the US. And we need this back. If you have this back, if you have this driver back, this is the best investment that any government can do, because out of this, you will create technologies upon technologies that will end up increasing life quality and increasing business for everyone on the planet.
Oh, absolutely. We had so many spin-off technologies from the space programs in the 60s. Guys, last couple of questions for you. If you weren't doing Rocket Factory Augsburg and you had to do another venture in space, is there something obvious you would do?
Now, for me right now, it's definitely launch vehicles because it's just way too expensive. I mean, look at just the propellant cost per kilogram. Do you know, if you look at 1 kilogram of satellite put into low Earth orbit, how much of it was propellant cost? If you ask this question, you realize it's a few $100s. It's like $200, $300, $400. That's crazy. Yeah. And we're talking about $20,000, $30,000 per kilogram, but the actual propellant cost has only been a few $100s. And this is obviously a gap that needs to be closed. It's difficult. It's extremely difficult. It's a lot of hardware. It's not like software. Software is relatively straightforward and easy. But something like this that is depending so much on hardware development, it is very hard. And it's not solved in 10 years' time. It will not be solved in 20 years' time. It's a continuous improvement process. And I'm convinced that we will knock down prices with fully reusable hardware at some point in the future, where we will be at a point where Jörn mentioned it's so affordable that you can really compare it in the future like a flight to Australia today.
Yeah, I fully agree. So you realized the 1 or 2 seconds pause that came after your question, where Stefan and I were looking at each other and didn't really understand the question, right? Because for us, there isn't
it's obvious
more exciting than doing rockets. Yeah? So it's very simple.
And I think the average person would probably agree, like rockets are just very exciting. And then the last question we always end up on, are you guys at the Rocket Factory, are you into science fiction? And if yes, what kind of science fiction do you like?
Yeah, look, I love all sorts of science fiction. I have to say that to me, sometimes it looks like that some science fiction is actually basically the baseline that engineers then afterwards are trying to create. It's like they are the first, they have some sort of idea. Back in the day, 20 years ago, it was all about lasers. I've done my entire PhD thesis on lasers, and I come to realize, man, lasers are just, there's nothing cooler in this world than laser everything. And this is my prime example, right? You saw lasers in science fiction in the 70s. And this engineers have eventually created this future. I don't know what it is, but what is the 3D printer that can basically create anything? There's a name for it in Star Trek. But
the replicator. Yes.
A replicator, exactly. Yes. And that's we want the replicator. Man, we want a 3D printer that here you go there and you just tell it what you want. It doesn't matter if it's a burger for lunch or if it's an Inconel thrust chamber for a rocket engine. The replicator just has to create it from scratch within a few minutes.
Oh, I think we certainly want many things from Star Trek. Also the ability to beam up and down, and certainly the warp drive at some point. Guys, I take it your Trekkies then as well. But
Again, thank you so much for the conversation. I think it was really interesting, but I wish you best of luck with your funding round, with executing on your business plan. I hope you're going to fly in 2021, and I hope that a few years later, you're actually going to fly humans to space.
Thank you very much.
Well, that's it for another nominal episode of the Space Business Podcast. If you like this podcast, please consider giving it a 5-star rating on your favorite podcast platform, such as iTunes. You can follow us on Twitter at podcast_space. Also consider supporting us at www.patreon.com/Space Business Podcast. If the podcast got you interested in learning more about the business opportunities in the space economy, check out my new online course on space entrepreneurship on udemy.com. The link is in the episode description. Lastly, if you have any feedback, including ideas for guests, and that may include yourself if you have an exciting space story to tell, or interested in being a sponsor, drop us an email at spacebusinesspodcast@gmail.com. I look forward to seeing you for the next episode.